Hello, Chris here. I'm back with experiment 12, and this experiment was all about soldering, and we had a few different types of things we were going to solder. Namely, most of them were to do with wires. So the first one we dealt with was a simple intersection of two wires, and the reason I have my clamps here is because I did not have a helping hands instrument with the little, the little alligator clips. Sometimes they have a magnifying glass as well. Something to suspend the wires while you solder. I did not have that, so what I ended up doing is, in the meantime, I had two of these guys and I stuck them side by side and suspended the wires between the clips, or the pinch points of these clamps, and used these. Wasn't the most ideal setup, but it certainly worked. So I'm going to try to magnify these. Let's see here. I'm going to see if we can get a good look. These are not, these are like my first soldering attempts ever, more or less, so they're not the greatest, but they definitely worked. So let's see here. Can we... Hopefully that looks pretty visible on camera. So as you see, there's a bead of solder right in the center. On the other side, it didn't quite surround the wire, but it did make a solid contact. This was not a cold soldering joint, sometimes known when you take the solder, you put it to the tip of your iron. Say I've got this guy, and I put some solder on the tip instead of putting the tip of my soldering iron to the metal, heating the metal, and then applying solder to the metal. So sometimes people will, apply solder to the tip of their soldering iron and then just kind of rub the melted solder over the metal. And that's what's called a cold soldering joint, at least that's my understanding. And that does not produce very strong joints. They're deceivingly weak. They look pretty good, not necessarily quite as perfect, but they look pretty good, but they break. And one of the things that I learned in this experiment is that solder joints are actually very strong. Now, granted, this setup, just pulling these wires, it's a bad angle. Like you're going to damage something. But what we'll see, I gave these a pretty good tug, and it's not going anywhere. It's just bending the wire that's before the joint. Yeah, as you can see, it's kind of. Let's see here. See if we can focus. There you go. So all it's really doing is trying to bend the wire that's not really part of the solder itself. So this was the first thing that was asked in experiment 12, and once you completed that, the second one was doing the same experiment except putting the wires end to end. So this guy, he looks, let's see, can we get, so as you see, it's kind of a similar deal where the side that I applied the solder on made very good coverage, but the side that I wasn't, it kind of seeped through between the wires and made definitely a solid connection, but just doesn't look quite as nice as on the side that you're soldering with. Now this one I gave pretty much the hardest tug I could. And I'll do it again right here. And I cannot pull this apart no matter what I do. Now, of course, the grip on this is not very good, but for such a small gauge wire and such a small amount of solder, this is a surprisingly strong contact. So whenever you do soldering and you think, oh man, it looks great, but it might be a little fragile, I should be kind of gentle with it. If you're gentle with it and it breaks, it's a bad soldering joint. Because this is rock solid. So, look, I'm bending the wire, just pulling with tension, and this guy's going nowhere. third part of this experiment asked you to modify your wall wart. Now in my case I'm not actually using this guy anymore, but what was asked was to take the ends, and keep in mind the wire for this wall wart is it's stranded, and so this makes it very difficult to take the wire and poke it into your breadboard directly, for example. I ended up poking these wires into the posts so that I could screw them down. But if you take a couple solid core wires, you know, and solder them to your stranded wires, then you can use this directly in your breadboard by just, you know, poking them in now, because now you don't have strands to muck around with at the tips of the wires. The coating you see here is the heat shrink that came with my kit, and all I did, you know, when I was trying to, what I do is I'd solder the wires together, and then, you know, take a nice little cutting of the heat shrinking, slide it over. And in my case, I don't have a heat gun like the book recommends, but a basic lighter will do the trick. Just get the flame going and put it, like, you know, about, like, if I were to show the distance, it'd be like that, you know, like it doesn't have to be where the flame's on the plastic, just kind of anywhere near it, and you just slowly move it, and you'll watch the heat shrink actually, like, you know, shrink around the wire. Now don't do it too much, like the book also warns, because if you do it too much, the heat shrink itself will start to split, and then it'll, you know, basically serve no purpose other than you'll need to peel it off and do it again. So this guy is heat shrinked, and so is this guy. So that is pretty much it in terms of the experiments. There was one additional one that the book asked us to do, which I did not do, and that one was to shorten a power cord. And it's just yet another exercise in shortening cords, and this time the power cord would be a little bit thicker gauge. I didn't do it because I don't really have one around that I feel like mucking around with, and I'm a little bit short on heat shrink. The heat shrink that came with the kit was probably only about, you know, that long, and I took like 2/3 of it just to do these two pieces. I probably could have used a little less, but I was a little bit paranoid about leaving any exposed bits of metal. So I decided to opt out of that one. But the same principles apply. And I think that's all there really was to experiment 12, so it's pretty much just a kind of a segue from the typical circuits that we've been dealing with to brush up on your soldering skills if you have not really done any soldering, and I'm in that boat. I haven't. Up until, well, I lied. There's one thing I had soldered, and I think I had indicated earlier on in the videos that the one piece I had soldered was this guy, the speaker, when we were doing that oscillator circuit with the put transistors and the NPN 2N2222 transistors. And as you'll see here, let's see if we can get this to focus. The inner solders were part of these, like they came with the speaker itself, like just to kind of solder the post to the speaker. I didn't do that part. However, that little browning you see on the fabric here is probably from me keeping my soldering iron a little too close for too long. So it definitely shows that there's some heat with soldering. But the outer solders are very strong, even for the very little contact they have with the metal. So these were the only other soldering jobs I've done, minus the wires that you saw just over there. So I am pretty new at soldering, but definitely starting to enjoy it more. And one thing that I highly recommend, well, no, I strongly recommend, is getting a good soldering iron. So if we were to, here, I'll pick this up and see if we can point him around. This soldering iron was recommended on that Australian video blog, the EEV blog, And this is a Heiko FX 888. And I think I got this for about 80 bucks on Amazon. And it's great because it's got variable resistance from 0 to basically like 900 degrees Fahrenheit, but you only really need to set your temperature about right in the middle if you're using typical 6347 solder. A little bit hotter if you're doing lead-free. Otherwise, this is a great, great soldering iron, and it actually comes with the default tip and the only tip. Let's see if we can actually get this to focus. This comes with a little chiseled tip. So highly recommend using this kind of tip, not a not one of those conical tips, because the surface area contact on the on the chisel is going to be much greater than a conical tip when you're touching it to your target, soldering whatever it is, whether it's a leg or a wire. So keep that in mind. The other thing I learned with soldering is I find that the target wires seem to heat up a lot more if you apply just a touch of solder to the tip of your iron, and but don't apply the solder that's now beaded on your iron to your target. Just have a slight little touch of it on your iron, and it kind of like accelerates the thermal heat on the tip, because then I find it heats the actual metal I'm touching much faster, and then you can apply your solder to the metal that's heated. So I don't know what you'd call that. That's not exactly tinning your tip, because tinning your tip is supposed to be where you're like trying to apply solder to the to the slight oxidation that sometimes starts to show on the tips, and I think the flux and the solder kind of eats away at the oxidation, which ends up like preserving the tip. I think that's my understanding anyway. So hopefully this has been kind of a nice little segue into soldering in general. I'm not going to go ahead and show how to solder, because I'm not going to kid anybody. I'm still new to it myself, but I highly recommend getting a nice quality soldering iron, if for no other reason than if you screw up, at least you know it's your fault and not the iron. But if you have a cheap iron and you screw up, it's hard to know, hey, am I doing something wrong, or does my iron suck? So, food for thought.